Hey guys, and welcome back to another new lesson here with topic 11. We're going to look at Envision 11.3. I hope you guys have enjoyed your spring break. That you took some time to rest, maybe stay up late, sleep in, just enjoy yourself, enjoy time with your family, get outside, enjoy that beautiful weather, and then really just take time to kind of de-stress a little bit and just connect with other people. So as you can see, if you're looking at me right now, I do have my hair down. It's getting longer, so the styling part of it's getting a little wacky, and I just kind of felt, take it easy, take a chill kind of day. So it is down. If I were to actually pull it down, it would pretty much almost cover my right eye here. So it's getting a little crazy, a little long, but still managing it. So sorry if this is a new look that you guys haven't seen me pull off before, but I'm gonna roll with it today. For today's Edpuzzle lesson, I'm going to, or I guess the 6th grade trivia question that I want to give you guys deals with pets that I had when I was in 6th grade. Okay, I actually had 2 pets in 6th grade. One of them was a dog, and another one was a fish. Okay, so I want you guys to guess at what type of dog I had, breed of my dog. You can try to guess the dog's name. It was a her. And then you can do the same with my fish if you want. You can guess what type of fish it was and what the name of the fish was. And then I want to hear from you guys, what pets do you guys currently have in your household? Now, if you don't have any pets right now, that's okay. You can tell me about a pet that you previously owned, or you can tell me about a pet that you would like to own in the future, potentially. So take a moment, answer that, and then we'll get started into our lesson. So the 2 pets that I had growing up in 6th grade, the dog was a German Shepherd with a little bit of a Black Lab mix, but it was primarily German Shepherd, and her name was Roxy, Roxy. And then the fish that I had was a goldfish that lived for 9 years, and its name was Speedy. It was just really fast. That's pretty much... That was the clever name that I came up with when I was like in 2nd grade, Speedy. So those were my 2 pets when I had in 6th grade. Anyway, let's go ahead and get started with today with rotations. Now, rotations can be kind of the more challenging types of transformations that we're going to deal with. Okay, it's not really something you guys have dealt with before, at least on the coordinate plane with figures and images. You guys have done rotations and you've heard of rotations prior to now. I know you talked about it, especially in 5th grade when you did the solar system, and you talked about how the planets rotate or they spin on their axis. And that's kind of really what we're going to do today with rotating figures on the coordinate plane, except we're going to be rotating them around the origin. Okay? And so I kind of have a little example here. We're going back to the house, the architect with the house in the patio who has reflected the grill to the other side and moved translated the fireplace to an awkward place. Anyway, but now we're going to look at the blue umbrella. So they want it on the patio somewhere where they can kind of easily move the umbrella and rotate it. Okay? So looking at this, the rotation, as I mentioned, is a transformation that turns a figure around a fixed point. This fixed point we usually call the center of rotation. Now, the center of rotation that we are going to focus on, I'm going to draw a little arrow out here, okay, is the origin. Okay, we are just focusing on the origin as our center of rotation. Now you could change it to be a fixed point that's already on the figure, or you could change it to be somewhere else on the coordinate plane, but we are focusing on just the origin. The angle of rotation is the number of degrees that the figure rotates. Now we are going to focus on 3 number of degrees is only for these rotations, because once you get into other degrees it makes it a bit more challenging and you have to have a protractor, but these 3 you can kind of get away without. The 3 we're going to look at are 90 degrees, 180 degrees, and 270 degrees. It's a funky 0. So, in these rotations, when we have a positive angle rotation, it means we're going to turn the figure counterclockwise. Completely counterintuitive to what we're all used to, but we're actually going to turn it counterclockwise when it's positive. So if it just says rotate the figure around the origin, assume it's going to be counterclockwise unless otherwise stated. And I'll show you on a coordinate grid why that's going to make a little more sense if we go counterclockwise instead of the general clockwise way. So if we have this umbrella that we're going to rotate 90 degrees, we're just going to take the exact square image that or figure that we have here and just rotate the point over 90 degrees. When we do that, okay, and we rotate it about the center, which we can kind of think of as the origin, okay, notice how the dark part moves over to the light part in this picture. So in this second picture, dark part went to light, or dark part went to the light part. The light part over here replaced that. The striped section replaced the light section up here, and you rotate it. Note that this transformation, just like the other transformations we dealt with, has the same size, the same shape, and orientation. Okay, we're not changing any aspect about it except its position, just like we did with reflection and translation. Okay, moving on here. So let's break down our first example. So what are the coordinates of the image of the trapezoid ABCD after a 90-degree rotation about the origin? To do this, and in this lesson you're going to want to use graph paper if you have it. That's going to be extremely helpful for you. If not, you're going to want to try to create these coordinate grids on just paper. Okay? So on your homework and in this lesson, it's going to be helpful with some graph paper. So if you need to pause and go grab some, highly recommend that you do that now. Okay? After you've drawn this image, to make the rotation of a 90-degree rotation, 90-degree angle about the origin, you're going to start with your initial point at the origin. And you're going to create a ray, which is a line that has an endpoint and an arrow that continues on forever. You're going to create a ray through one of the original points on the original figure. I always recommend taking the one that's closest to the origin. So in this case, it's going to be point D. So I'm going to try my best to draw a ray, straight line ray through point D. Remember, ray, endpoint to the origin, and that line continues on forever. Then with your protractor, if you have one, you can put it up to the screen, or you can use a ruler, but you're going to create a 90-degree angle. Okay. Now, to do this, I would draw, but I'd have to make a little mark. I would measure this out to be 90 degrees. And do the same thing and draw a ray. Trying my best here. Going the other way, and here's my 90-degree angle. And you're going to take this point and rotate it the 90 degrees to its new location on the other ray. Okay. Now I know this may be a little confusing, but there's a simpler way that you can put it. Okay, you made this 90-degree angle from this ray to this ray. Point D and what we would call D prime needs to be the exact same distance from the origin. Notice that this is 1 over and 1 up. So on the opposite side, this also has to be 1 and 1. So point D, or D prime I should say, is going to be located at that point. We would say negative 1, 1. Okay? Negative 1, 1. You would do the same thing with all of the other points. Okay, when you do A, notice how A from the origin is 2 over and 3 up. Now it's not going to be the same on the opposite side. It's not going to be 2 over and 3 up. You're not going to get the same thing. That would actually create a reflection. We're not creating a reflection, we're rotating it. Okay, so same thing, you would create your, I'm going to do my best here, create your ray through here. Now I'm going to do the exact same thing, 90 degrees, measure that out to the other side. And I'm going to get, marking this out. Okay, do this 90 degree, it's a little harder to see. There's your 90 degree angle, and you would actually rotate it to this point. And there's A prime, which then is at -3, 2. You would do the same thing with the other points and rotate those also 90 degrees. When you do that, B to B prime becomes -3, 4, and C to C prime becomes -1, 5. Now you might be looking at that and asking yourself, how in the world would I get these points just by looking at them? Well, there's actually a pattern that's happening here. Let's go on to the next slide and I'll show you. So here's a much better drawn picture of the rotation that's happening. You are taking this figure and you are literally rotating it, turning it on its side 90 degrees. So, as I mentioned, you would draw a ray from every point to get to its new point and plot that same distance from the origin as D. And here are the points that we got. Now, here's the pattern that's going to help you figure this out. Okay? Take a look at from point A to A prime, B to B prime, C to C prime, D to D prime. Okay? Notice this was 2, 3, and this was -3, 2, 4, 3, -3, 4, 5, 1, -5, or sorry, -1, 5, 1, 1, -1, 1. Look at the pattern that's happening here. So if you notice, the x coordinates, right, x and y, and same thing above here, the x coordinate in the prime or the rotated point is actually the opposite of all of the y coordinates here. Look at that. So, when you're rotating 90 degrees clockwise, okay, your x-coordinate is always the opposite of the y. And check this out, your y-coordinate, 2, 4, 5, 1, is just the x-coordinate from the original point, 2, 4, 5, 1. Okay, and this works for every 90 degree rotation counterclockwise around the origin. So this table right here is going to explain that rule, and this is a table. I would pause the video now, just this table, and write down the rule for each one, and I'll kind of go over them. You'll need this for everything you'll do and even on your homework. Okay? When you rotate 90 degrees, and this is for only counterclockwise, okay, as I said before, the reason we go counterclockwise, okay, is dealing with your quadrants. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. So that's mainly why we go counterclockwise. You can go the other way. That's one of the main reasons. So 90 degrees, when you have your original figure point, x, y, the rule is you take the opposite of y, and that becomes your x, and then your original x becomes your y coordinate. Okay? Then for a 180 degree rotation, your original figure point, x, y, then becomes the opposite of x and the opposite of y. For a 270 degree rotation, your original point figure, xy, then becomes written in the prime point of the image as your x-coordinate is whatever the y was, and your y-coordinate is whatever the opposite of x is. Now notice that I'm saying the opposite of x. I'm not saying negative here, okay? Because if this was actually negative, okay, we would take the opposite. We're not going to write the negative. So if this was -2, then we're going to take the opposite of -2, which would just be 2. We're not going to make it, keep it as a -2. So you would always do the opposite. So that's why if you want to make a little note and say that it means the opposite, that would probably be a good idea when we're talking about these negatives. I'm going to stop the video here now and continue on to video part 2.